welcome to my channel. Today I'm gonna tell you about the performance characteristics of the DC shunt motor. We'll see the characteristics between the armature current and the armature torque. We have the linear characteristics in the armature current and armature torque. Now let's see how that we have get this linear form. Okay. First, we know that the formula, the torque of an armature torque is directly proportional to the flux and the armature current. Now here in the DC shunt motors, flux is taken to be as a constant value. Okay, so armature torque depends on the flux and the armature current, whereas the flux is constant in the DC shunt motor. So TA is directly proportional to IA. Now we can equalize it by giving a constant value like TA is equals to KIA. This is similar to the equation of the straight line like y is equals to mx plus c, where c is the constant value, and here it's quite simple as y is equals to mx plus c and TA is equals to k into IA plus 0. So it is in the form of a linear form. So a straight line is formed in the manner. Okay. Now the curve is a straight line. Now shunt motor are not started on heavy load because they need high starting currents, which will affect their voltage regulation and electrical installations. This is a quite simple point. It should be added in this question because we are talking about the DC machines. A heavy load is not given to a DC machine directly because it will affect the current as well as the voltage regulations in the DC machine, which causes a great damage to a DC machine. So we should not give a heavy load directly to a DC machine. Now, secondly, we will see about the characteristics of the speed and the armature current. What is the characteristics of the speed and the armature currents are? We know that the formula N is directly proportional to EB by pi. Okay, EB by pi, where EB is the back EMF and pi is the flux. And we know that N is directly proportional to EB by the above formula, where EB is the V minus IA. Here, IA is a quite small value, so we will neglect it. So, EB is equals to V, which is approximately a constant value. So, speed is always a constant value. This is the graph of the speed and armature current characteristics, okay, which is a constant value of N. And the again important point is, but for practical applications, shunt motor is called as the constant speed motor. Okay, because it will maintain a constant speed. We know that the formula of the constant speed, that is the synchronous speed, is ns is equals to 120 f by b. It moves in this synchronous speed. Now let us see the third characteristics, which is the speed and the armature torque. We have observed in first equation that T is directly proportional to IA, and second equation that N is P, that is speed is inversely proportional to the armature current. Now from 1 and 2 we can easily observe that speed is inversely proportional to the torque. That's the equation. And here we can plot the graph for it, which is in the form of a slant form, which is inversely proportional. As N increases, T decreases. That's it. This is all about the performance characteristics of a DC shunt motor. I have already uploaded the video of the DC machines working and applications. And I will also upload the electrical installations, which is the fourth chapter in the BAA. Okay, please don't forget to watch all these videos and don't forget to like, share, and subscribe to my channel and click the bell icon so that you are notified to my videos. Thank you.